All right, this is the second day of working with graphs of sinusoidal functions, and today we're going to talk about shifting the graphs left, right, up, down, and vertical and horizontal dilations of the graphs. So the good news is that you've actually learned all the core components that you need in order to shift around sinusoidal functions because, oops, I put a stray mark on the paper. Okay, because the midline acts as the vertical translation, the amplitude acts as the vertical dilation, and the period acts as the horizontal dilation. And the only other thing that there is a horizontal shift left or right, which we talked about a little bit last class in the sense that the cosine function is the sine function shifted left by pi over 2. Okay, so let's first talk about how the midline, amplitude, and period affect the graph of a sinusoidal function. So we're starting with these core parent functions for sine and cosine, and notice that they have an amplitude of A, the midline we call D, and the period will come from the B value. It's not equal to B, but it comes from the B value. Notice that I have not yet added in horizontal transformations. That will come later. Okay, so a vertical dilation is legitimately just the amplitude. It is the distance between the maximum and the midline, or the minimum and the midline. The midline is the up or down shift. It is your D value. And then a horizontal dilation happens by a factor of 1 over B, where B is this value right here in front of theta. And so the way I think about it is that period is given by 2 pi over B. So if you have a B value, take 2 pi and divide it by B, and you have the period of the graph. Okay? So let's take a look at a graph and see if we can figure out, do you see how we have A, B, and D? A is amplitude, D is midline, and P is 2 pi over period. B is 2 pi over period. And let me go back here. Notice that I have this equation, P equals 2 pi over B. If I cross multiplied by B, I would get BP equals 2 pi, and then multiply or divide by P, and I get B equals 2 pi over period. So I can say that P is 2 pi over B and that B is 2 pi over period. Both equations work. Okay, so here's my graph. We have a sinusoidal function. They're laying out for us as clear as a bell. Period is pi, amplitude is 6, midline is 3. So here's the deal. Your amplitude is your A value. Your midline is your D value. Your B value is 2 pi over your period, and they told you your period is pi, so your B value is 2. And they didn't ask us to do it, but I'm going to go ahead and write out the entire function. H of theta equals 6 sine of 2 theta, putting that in parentheses, plus 3. That's my sinusoidal function given the graph. Okay, next page, we're going to go ahead and write the functions with a little bit less scaffolding. And do you notice that we're asking you to write one sine function and one cosine function, because you can actually do either because they're just horizontal transformations of each other. So what I like to do first is kind of sketch in the midline here, clearly at -3. By the way, the only thing that will change if you write a sine or a cosine equation is the horizontal shift. So my amplitude is the same, my midline is the same, and my period is the same. So I start with those. My midline, like I said, we're shifted down by 3. The distance from the midline to the max, that distance here is 2, so that's my amplitude. And then notice for the cosine function, I'm starting at the maximum value, and I go over to 6 pi. So my period is 6 pi. If period is 6 pi, B equals 2 pi over 6 pi, which is 1/3. So of course for sine, I put in sine. For cosine, I put in cosine. My B value is 1/3 for both of them. Now I just got to figure out if there's a horizontal shift. So for my cosine function, my parent cosine function starts at the maximum value. That's where this one starts, so there is no shift left or right for the cosine function here. So I'm just going to put in, I could use an x or a theta, I don't think it really matters, but there's no horizontal shift. That is my entire cosine function, y equals 2 cosine 1/3 theta minus 3. Sine is a bit different because it looks like Remember, on a core sine function, we typically start at the origin and we're heading upward. That means that my starting points for sine would be one of these 3 points where I'm crossing the midline and heading upward. And I can choose any one of them, and they will all be representing the same function because I'm just shifting left or right by a period. So let's choose to shift right, and it looks like we're shifting right by 9 pi over 2. So I basically have theta minus 9 pi over 2. I want to point out that I went ahead and shifted here in parentheses. My theta minus 9 pi over 2 is in parentheses because your b will need to be factored out of that shift in order to represent the function correctly. The other option, by the way, that I could have done, I could have said 1/3 and then theta plus 3 pi over 2. That would have represented a left shift to 3 pi over 2. Those would have both been completely fine. Okay, the next one I have here, I always like to put the midline in first. My midline is at y equals 1, so I have a plus 1 out in front. Looks like I have an amplitude of 2 again. So I have a y equals 2. And then, of course, for sine, I have sine, and for cosine, I have cosine. To find my period, it looks like I go from pi over 5 to pi if I go from max to max. So my period is 4 pi over 5, or 4/5 pi. So that means my b value, which is 2 pi divided by 4 pi over 5, is 2 pi times 5 divided by 4 pi. 2 pi over 4 pi simplifies to a 2 in the bottom, so my b value is 5/2. So you will have to do some manipulation computations to figure out your b value there. Okay, so now I just need to find if I've got horizontal or vertical shifts. By the way, I haven't mentioned this. This is called a phase shift because you're changing, think about the phases of the moon that go in a cycle of 28 days where you have a full moon and a new moon and a half moon and a crescent moon. Well, if you shifted them by a week either way, you would have a shift in the phase. So we call this a phase shift. So I need a theta. Oops, I have my eraser on. Okay, need a theta there, need a theta there. For sine, it looks like I don't have any kind of phase shift because I intersect at the y-axis and the midline and I'm heading upward. So this graph, or this equation, is done. Check, happy. For cosine, I have shifted. I could go right by pi over 5, or I could go left by negative 3 pi over 5. I'm just going to go right by pi over 5, so I'm going to subtract out pi over 5 from my theta, and then I'm done with this equation. Okay, so next example says, what are the period and the amplitude of this function? Okay, so the amplitude, first I draw in the midline, then I draw in the max, and I figure out the distance. So I know my amplitude A is 2. So I need this guy or this guy. These two have amplitudes of 4, so they're not correct. So my period then, of course, is, I could try to go max to max or min to min, but I think it would be easier to use the midlines because they're on hash marks or cross hashes of the graph. So my period is from negative pi over 2 to pi over 2, which is pi, and my answer here is A. Example 4, I have a max at 0.6, and then the next min is at negative 4. So the difference between the max and the min, 6 minus a negative 4, is 10. Divide that by 2 to get my midline. To get my amplitude, sorry. To get my amplitude, that means it's got to be either C or D. Notice that all of my midlines are at 1, so that's not helpful, but I do know that I don't need an amplitude of 10. Then I just have to figure out my period. Looks like since I go from the max at 0 to the min at pi over 2, that's half a period. So the full period is going to be pi, but remember that my b value is 2 pi over period, or just 2, which tells me my D is correct. Okay, another one. we have here what happens when, which graph? So they're giving us an equation, and they want to know which graph. Well, first we need a midline at -1. This midline's at 1, so it's not A. Looks like all of my other midlines are at -1. So I need to find an amplitude of 3. This has an amplitude of 3. This has an amplitude of 3. This has an amplitude of 3. So they all fit the amplitude in the midline, so my issue must be the period. If my B value is 2, then my period is 2 pi over 2. So my period is going to be pi. So let's see if we can figure out one with the period of pi. Here from max to max, it looks like I go from pi over 2 to 5 pi over 2. That's a period of 2 pi, so that doesn't work. This one from max to max goes from pi over 8 to 5 pi over 8, so that period is pi over 2. Here we go from pi over 4 to 5 pi over 4. That's a period of pi. Okay, so I already showed you an example with a phase shift, and now I'm actually teaching you what a phase shift is. When I say the examples with the phase shift, those were these two, where one of our functions, sine or cosine, had a horizontal shift. Now I'm actually going to introduce what this is. The horizontal translation is called the phase shift, and it's basically shifting the graph of a sine or cosine function left or right. Okay, so this guy, they want to know what the graph is. Let's look here. The midline is -1. All of my examples have a midline of -1. The amplitude is 3. All of my examples have an amplitude of 3. My period, if I go from max to max, my period is 2 pi. All of my examples have a period of 2 pi because we all have a coefficient of 1 in front of x. So which one is it going to be, guys? Notice also that this example and this example have a negative out in front. That means the graph has been flipped over the x-axis. So the easiest way to do this problem is to think about, hey, normally cosine starts at the max, this one starts at the min. So it's legitimately a regular cosine function with no phase shift flipped upside down. Except the one here that is a cosine function flipped upside down has a phase shift in it. So it can't be this one. So then we think, what if it's just a plain cosine function? Well, if it were a plain cosine function, then it would need a phase shift right by pi. Well, the plain cosine function without the negative out in front doesn't have a phase shift. So it's not this one. So now let's go take a look as if it's a sine function. So it could be a sine or a cosine function. That's the beauty of this. So standard sine function with a positive leading coefficient looks like it is shifted right by pi over 2. But a right by pi over 2 is a negative pi over 2, and this one has a positive. So if we start with a negative and our sine function was flipped upside down, that means when it crosses the midline, it would be going downward. Okay, so that means this is our starting point right here, which is a right shift by 3 pi over 2, which is exactly what this one has, and D is our correct answer. And I think I just have 2 more problems to get through. I don't know if I'll get them on this video or have to do another video, but we'll see. So we're trying to find the equation for this graph. Notice that all of my options have the same amplitude, the same midline, and the same period. So this whole thing is just a question of the phase shift. So if we use a cosine function, we needed to phase shift right by pi over 2 or right by 3 pi over 2. Those are not options. By the way, there are no negatives in front of the 2, so there's no reflection over the x-axis here. So if I use a sine function, it looks like I'm going right by pi over 4 or right by 5 pi over 4. So a sine function that's shifted right by pi over 4 is C. And then the last question goes back to kind of our task model FRQ3, but they're giving us our points. And let's go ahead and write them in. If this is 216, this is 511, this is 86, this is 1111, and this is 1416. Let's figure out A, B, C, and D. Well, the midline is 11. That's our D value. The amplitude is the distance from 11 to 16. That's our A value. The period is from max to max, from 2 to 14. So the period is 12. So the B value is 2 pi over 12, or pi over 6. And then They're asking us to do a sine function, so we have to shift it right by 11, so our C value is negative 11.